Okay, this is part 2 of today's lecture on electromagnetism. In the previous portion of today's lecture, I introduced to you Amperes Law, which is a fundamental relationship that describes the following: the cause of a magnetic field. A magnetic field is caused by a moving electrical charge, by a conventional current, for example. So then, therefore, let's immediately ask the following question. Does it work the other way around? In other words, does a magnetic field cause an electrical charge to move? Okay, go ahead and pause this lecture and then take a look at the folder at the demonstration video called Faraday's Law Demonstration. So do so now. Okay, now that you've looked at that demonstration, the answer to this question is no. When the bar magnet, for example, was just sitting there inside of the solenoid, you didn't see any current flowing by means of the gauge that I was using in that demonstration. However, when I moved the magnetic field near the coil of wire, then an alternating current was generated. So a moving magnetic field causes an electrical current. In other words, a moving magnetic field exerts a force on a charged particle, causing it to move. If, for example, a magnetic field did exert a force on a charged particle, causing it to move, that would violate conservation of energy. Where did the energy necessary for that to happen come from? However, if I do take the bar magnet and I then move it, well, then some of the energy that I am using to move the magnet, that is then ultimately being converted into the energy associated with the alternating current that you saw. Okay, this qualitative description right here that I just wrote down, essentially this sentence, this summarizes in a nutshell another fundamental relationship between electricity and magnetism called Faraday's Law. There is, of course, a very detailed way of describing all of this mathematically. The mathematics behind Faraday's Law are particularly difficult. Once again, it's a topic that we save for the AP level. But basically, to summarize Faraday's Law in the following manner, a moving magnetic field causes an electrical current. In other words, it exerts a force upon a charged particle, causing a charged particle to move. And then immediately, let's go ahead and take a look at a basic application of Faraday's Law. At this point, go ahead and pause the lecture here, and then take a look at two things in the folder. Take a look at the generator demonstration, and also take a look at my generator screenshot video as well that shows the demonstration in detail. So take a look at those two videos now, they're both short. Okay, so now that you've seen those videos there where I demonstrate for you and show you exactly how a generator works, basically you have the following situation. Some sort of energy source is necessary to move a coil of wire near a permanent magnet. When that happens, you basically have a moving magnetic field that then creates an electrical current in the coil of wire, and specifically, it's an alternating current. So an energy source is used to move a coil of wire in the presence of a permanent magnet. This generates an alternating current. This is how we always generate electricity on a large scale. This ultimately explains why you have coming out of an ordinary wall socket an alternating current. Some sort of energy source is necessary to move a coil of wire near a magnetic field. This then creates an alternating current. So if you're talking about, for example, generating power in this manner by using a coal-fired power plant, Basically, the chemical potential energy associated with the coal, and it's a very dense form of chemical potential energy, by the way. Well, that chemical potential energy is then used to heat up water. It turns it to steam, and then the steam is used to push what is called a turbine. Basically, me cranking, for example, the hand crank generator, the coil of wire in the presence of the magnetic field. So ultimately, how we generate power, generate electricity on a large scale, is making direct use of Faraday's law. Okay, I'm going to go ahead and stop there. We'll just summarize then this unit on electricity and magnetism with this final lecture here, part 2, covering now Faraday's law. Today's shirt was Black Sabbath.